Thanks for showing up. I'm JP, and I'm here to talk about how easy it is to build your own Trojan hardware at home, even if you're not a hardware techie person. I'd like to thank Black Hat Asia for letting me speak this year. This guy here, I am a computer security consultant at Foundstone. I do mostly pen testing of all kinds. I like to think of myself as a breaker of things. I'm not nearly as good at fixing things as I am breaking them. My personal interest areas are like wireless security, portable, and by portable I mean like little gadgets and things, not necessarily like mobile security, not phones and stuff. Hardware, which is a newer venture for me. I've learned all this in the past few years. I came up as a software guy, so just trying to come from the perspective of people here that are not hardware engineers. I didn't come from that side either, but I've been learning it. And also physical security. A couple of the projects that I've worked on are Katana, which is a multi-boot USB flash drive. VRNG is like a wireless hacking toolkit. It's a bunch of Bluetooth hacking stuff, and some hardware I'm going to talk about today. And I've spoken at several other cons before, exclusively in the US, so I'm super excited to be here in Singapore speaking at Black Hat Asia. So the goals of this talk, I want to discuss building Trojan hardware at home. And we're very used to hearing the concept of a Trojan, but going back, many, many decades, that's always been a software side of things. You always think of downloading a file, clicking on it, and all of a sudden you're infected with, something, some sort of buzzword item. Big focus here is you do not need to be, keep emphasizing this fact, and I'll probably say it again, you don't need to be super hardware hacker person to perform these types of attacks. You'll see sort of how easy it is. We'll get a little bit technical, but I'm going to try to stay a little bit on a broader scope. I'm going to try to remain as platform neutral as possible. I'm not targeting any specific vendor here as much as we'll be discussing types of devices. Obviously, I'm using a vendor item. Kind of ignore that. That's totally useless. That is not the information you need to take away from this. This is vendor neutral, sort of a discussion. And I want to show you how easy it is to perform these hardware attacks against common everyday things you find in the home, in the office, on the market. Just stuff you see, tons of stuff you see in this room. So let's simplify hardware. How many people here mess with hardware either as a hobby or professionally? Okay, I see about half a dozen hands. And that's what I really found in the security field in general, where a lot of software people either came from programming, IT, some sort of administration, and then moved into security. And there's almost no people that have done hardware and moved into security from there. A lot of people that have gotten into it, like I have, it's always been sort of a curiosity, hobby thing. There's a few people out there that came from hardware that are doing security. But as a field, it seems like the hardware side of thing really gets overlooked. So just going to make it a little simple for you. We break it down so the hardware doesn't seem so mysterious. So what do we normally have? We have a PCB board, a printed circuit board. You've got your tiny single-use components like a resistor, an LED, the crystal clock, capacitors. You've got some specialized chips like your RAM, maybe a controller like an Ethernet controller or a USB controller that all it does is interpret data from one side to USB and back, so it doesn't do lots of things. You've got your primary processor, which is kind of the mothership, controls everything. You've got your input-output ports, and these are sometimes on the board themselves, inside, and then sometimes it's like your USB, Ethernet, VGA, audio. All of those are, information out, information in sort of ports. And we also have firmware, and this isn't necessarily strictly physically hardware, but almost everything, all the devices we use nowadays, nothing's written, like flashed on hardware side. A lot of it is controlled by firmware. So we're going to encapsulate firmware as hardware today. So we're talking a little bit about the firmware side as well. So modifying hardware. What do we need to look at in order to get started? We want to see what's in the box. I've become obsessed with taking apart everything I buy now, which is not good because I'm very bad at putting it back together. I get really curious and open up and I look up all the parts and stuff, and then it kind of just sits there and I'm like, oh, that's my TV. I should put my TV back together. I kid you not, my TV right now is disassembled at home. So it's not really that difficult either. It's sometimes that's a good thing to demystify hardware. If you're not used to seeing a PCB board, you open it up and it's like all these lines going everywhere, all these parts, and it looks very mysterious. But then if you kind of break it down into its actual components you care about, there's like 4 points on there of the main chips. You don't care about a lot of the other stuff. So that helps demystify. So you open up the box, see what's in it. Even from the outside, you don't have to open it up. You can see there's USB connectors. You might have a PS2 connector, RJ45 Ethernet adapter. On the board, you might have things, and if you're not hardware, you might not be familiar with these sorts of I/O protocols, but UART, I2C, SPI, these are ones that are used at a much lower level than the users generally interact with. Sometimes inter-chip communication occurs over these sort of standardized channels. What I suggest is if you want to play around with this, get stuff cheap. Don't buy things. Beg friends for them, as I do constantly. Find them at thrift stores or used, or a keyboard with 5 missing keys is excellent for practice. And then you can see that the hardware inside, if you want to get the new version for an actual test. I definitely recommend going cheap. eBay, Craigslist, Taobao, wherever. What's the purpose of the hardware? If it's a thermostat, I don't really know if I care that I can attack it. That doesn't really gain me anything. So maybe look at the purpose of the hardware to see what sort of vector you could possibly use, and how it interacts with the target. Is it wireless? Is it wired? What sort of USB, Ethernet? What is it going over? And leverage your attacks that way. So what do you need to play along? I'm a Linux guy. Big promoter of Linux, love Linux. But sometimes you just have to have Windows for certain development tools, or if you're testing these sorts of attacks against systems, it's good to have a development system. And in that same sense, you should probably, if you're testing an attack that's universal, have all the major OSs up there. Again, cheap target hardware, why spend the money? A lot of the programmers to flash new firmware are really cheap. It's not something you have to be a corporate giant to afford a development team to get these things. Software is free or open source community. The hardware is like $40, depending on where you get it from. Some time to learn it. The Trojan device you'd like to embed. And obviously minions are very helpful when you're trying to do sort of mad science projects. All right, so number one, let's start off with USB, the attack vector I'll be talking about most of today. So in this scenario, let's hide our malicious little Trojan hardware inside of an existing common piece of hardware. And I'll be talking about stuff that you can actually see. I've got some stuff sitting up over here. You can poke at it later on. Many devices, you'd be surprised how many of them have, let's say, large open cavities. These are open free spaces inside the device. Your phone is built as compact as possible, but your mouse, it's not, because you don't want to hold a mouse that's that big. It could be that big, but you don't want to hold one that big. So a mouse has the contour of your hand, but the electronics inside are very, small. It's flat at the bottom. So you find, as I've been opening up everything that I own, a surprising number of places where the cavity is already open, or you can cut out some plastic that really doesn't do anything other than, it was plastic mold injected that way, to fit in other devices. You attack the host device that it's connected to. So I don't really care about targeting, whatever I'm buying. I want to attack the computer that I'm, that I would assume that the target user is plugging the device into, and I want to leave it functional. So if it's a keyboard, I want to make it be a keyboard, because if you modify it and it's malicious and you plug it in and it doesn't work as a keyboard, you've got about 10 seconds before the user is like, well, probably not thinking it's malicious as much as, why did I spend, $10, $15 on this keyboard? It's not working. They unplug it, ship it back, or throw it away, or whatever. So we want to make it do what it was intended to do, plus our little bit of fun. To this end, I did a Kickstarter project, and I developed an open source hardware platform for these exact sort of attacks. If you're familiar, Arduino, do people know what the Arduinos are? We have some people here. So it's an open source, very easy user base for hardware stuff, not just hardware hacking, like security side, but in general, if you want to get into hardware at all, it's a great platform to use. And there's a lot of different boards out there, but I wanted to develop one that was specific for the security community. So I had to talk to friends and tried to think what would be the easiest way to make it accessible to the non-hardware folk, but also make it really useful for security testing. So it's Arduino compatible. I can incorporate a lot of other hardware that's designed for Arduino stuff, so like things like a Bluetooth adapter can be added to it very easily. And I wanted to make this project as easy as possible for the non-coders and engineers. Again, trying to bring it into a larger scope. So I was successfully funded last year, and I'm really grateful about that. So a little bit about the platform. I wanted to make it easy, so most of the userland configuration is a micro SD card and text files. There's no interactive front end. You don't have to write your own source code or compile it or anything. It's all SD cards and dip switches. I put the dip switches on there so you can have lots of different attack scenarios. So if you're not embedding it and you're just plugging it into computers that you want to attack, you can have specific targets for Windows XP, Windows 7, Server, 8, OS X, Linux, whatever you want. Have them all on you at once. Plug and play. I've got the project site at the end, so you don't need to write that down right now. What we're going to focus on with here is keystroke injection. So essentially, the glitch is able to emulate a keyboard. This functionality also exists for other Arduino-compatible devices. So it's essentially, when it's plugged in, it says, I'm a keyboard computer, and then computer goes, cool. And then it starts sending the data that's the same as data for, you're sending packets and keystrokes onto the target system. So you essentially make it into a keyboard. So it's going to type out stuff, even though the user is not typing things. You're playing it out as if the keyboard is typing certain sort of attacks that we can set up. The nice thing about this sort of scenario is it types very accurately. It types very, very quickly. I have to slow it down most of the time because it can type faster than the computers can buffer it. So there's some playing around you have to do with actual timing. And there's no human required. So I can ship a attack device to somebody, tell them they've won this awesome promotional, and they plug it in, and I'm 10,000 or 1,000 miles away. I don't have to be anywhere near it. Or if I'm physically in the building, I can plug it in and walk away. So that's like a 5-second walk, plug in, you're gone, and you don't have to be around at all for these sort of attacks to take place, which is nice and handy. Works against anything with a keyboard. So even if you have USB hostbin on your iPhone, this could potentially do something against it. As long as it accepts a keyboard, generic brand keyboard, these sort of attacks will work against the system, which is nice and handy. I wrote a scripting language to be interpreted for these keystrokes. So because you can't type in, there's no ASCII character for F3, I had to write something to be interpreted to say, oh, I want to type out, F3. This is a little bit about the language. You'll see some examples actually just next. There's a lot of documentation online, so I won't talk about the language too much. But this is a simple example. For any of us computer linguists out there, can anybody guess what this does? It would make me very happy if somebody can figure out what this does based on the language syntax that they've learned in the last 10 seconds. What? And then, that's right. You got it, gentleman in the front. So it runs Notepad. We're doing GUI R, which for Windows gurus here, we'll open up the run, types in Notepad, hits enter, pops up, says hello Black Hat Asia, and then Alt F4 closes it. So I'm glad that somebody within 15 seconds is able to decipher it. That makes me feel good that my language is somewhat syntactically easy. It looks very big, right? It looks like you have to write a lot for it. I have a generator that you can point and click your way through all of this. Other than typing out the word Notepad, you can point and click your way, so you don't have to memorize all this and get it exactly correct. There's a generator for you, makes things a lot easier. Okay, so moving on from our Trojan side, so we've set up our Trojan device to perform attacks, and I'll talk a little bit about those exact scenarios later, but say we've learned enough, we can set up our device, now what? We want to make it into a Trojan. So let's make this super simple. We'll grab the closest mouse to us that's used in many corporate areas, and this was just the one that happened upon, I'll just get the first one from a thrift store, the USB hub, and the glitch. So the bottom two are completely inconsequential. What brand they are, it doesn't matter. These are completely vendor neutral. They just happen to be a USB hub that's small and a mouse. Step one, crack open the mouse. You can see the different color PCBs. These are actually two different mice. The reason I have it up here is most mice, you flip them over, you unscrew the one screw, it pops right open. It's about a 3 or 4 second process. Actually, if somebody wants to grab that mouse right there, if you want to, you guys can pass it around. Don't steal it, but otherwise it's okay. Yeah, see, that's okay. If it I don't feel bad. So we'll pass this whole thing around. It's a good-sized room for that sort of thing. It's okay. If it's in 23 pieces when it comes back, I'll be okay. I won't be heartbroken. I just wanted you guys to get some hands-on experience with it. You can poke at it. So generally with a mouse, there's two different options. Either, and most of the time it has to do with the quality, either the USB pins are soldered to the motherboard, or there's a little connector. Connectors are nice and easy for us non-solder folk. And then you take it out, the little scroller mouse, which I didn't give you because it falls out all the time and I'm constantly losing them. You take that out, which it just snaps in. And you've got this large open cavity, as you can see when you pass it around. Actually, pass around the top of it as well. You can kind of cover it up just to see. Thank you, I appreciate it. How much space is actually in there. Step 2, awesome little USB hub. We don't need a lot of the USB hub, so what we're going to do is sever the connection from the hub to the host computer. We'll cut that, or unsolder it actually. We only need 2 USB slaves, the place where you actually would plug in your devices. You could keep more. One of them, the attacks that I've done before, is actually I used the third one, inserted a micro SD to USB adapter, and mounted that disk to perform attacks. So I would leverage the keystroke injection to mount a disk and then copy files over, or execute things based on that. But in this scenario, we're just using the single one. So we want 2 ports there. We'll cut off or unsolder 2 of them. We'll leave the other 2 there and cut off the very end where you'd actually plug in your device to the USB hub. This will all come together in a second. One thing that I thought about this, I had this idea when I designed the glitch, was I want to be able to make it embedded. If you see, when you have this is a micro USB connector, which you use to program and interact with the device. But if the adapters for micro USB to USB are really long when you're looking at this sort of scenario of wanting to embed it in a tiny device. It makes it almost twice as long. The smallest adapter I've found makes it about twice as long. So it's almost the exact length of the glitch. So you have, instead of being like 2 centimeters, it's like 4. And that's a lot of space. So I added these solder pads on the top. So as an alternative to the USB port, you can add these 4 lines. So you can either solder the other ends or plug them in or whatever, so that they're just wires, so they wrap around very easy and they're much easier to embed in that sort of scenario. So it does take a little bit of soldering here, but it's not too terribly difficult, and I do have some step guides in the documentation. So people that aren't familiar with USB, there's 4 wires, and thankfully those 4 wires are color-coded. Because a lot of times with this sort of thing, you're cutting a wire, and then you have 4 wires. And if they're all green, you have a lot of testing ahead of you. But with USB, unless it's a really, really poorly manufactured device, it almost always follows the standard, unlike me, because my white line is yellow. But that was because that's what I had, the physically closest wire that I had to me. That's my excuse. But normally if you cut open a wire, you pull back the cover, you see it'd be red, white, green, and black. And they're associated with their data lines, so it makes it way easier for us to match pairs up exactly as they should go. So in this scenario, we've unplugged the little connector, which is the USB cable, unplug it from the mouse, cut it. We're going to embed the side on the right, we're going to connect to the USB hub. The side on the left, the USB hub cable that's going to the computer. Side on the left is the USB cable going back to the mouse. And that makes sense a lot more when I have my child drawings of it that I made in Paint, because I'm not very good. So these are our three little devices, right? Step 1, and then like 3, 4, step 2, 3, and 4 all together. We sever a lot of connections, we connect things, but you can see the original USB cable now goes to the hub. The hub is then connected to the glitch and the mouse. And then we put it all together, and it fits nice and happy and inside the mouse, the very common and easy to find mouse. So that makes things convenient. You now either ship the mouse, replace it, swap it out. If you're using a common hardware like that, you just walk into a place and you can swap it out. Lots of promotions are good. You buy the nice big fancy mouse, and you say, hey, thanks for coming to Black Hat. You won this big prize, and you get it shipped to you. You're like, sweet, and you plug it in, and then don't do that, anybody. That would be bad. So if you get a mouse shipped to you within the next month, you might want to crack it open first. So that's the scenario for the mouse, and that's generally, kind of what I'm talking about here, but I'm going to go over a few other vectors just to make you think, so your mind doesn't go, I should never plug in a mouse again. Your mind should go, I should never plug in anything ever, any that I haven't disassembled entirely to my home or corporate network. So that's what it is altogether. I don't know how far it's gotten around, but it's not very difficult to see. I'm going to walk off camera, sorry. You've got your little tiny hub, you've got the glitch. I should probably shield it from touching other parts of the wire, but I haven't. And then you've got your cable sort of going out this way, and then you close it all up, and it's a mouse that scrolls and works just fine, and everything is great. And the little light comes on the bottom, and it closes just fine. There's plenty of space in this mouse. Screw it back together, and it's all good. Some payloads. So for these sort of attacks, you generally want to target a specific OS. Because if you want to open the command prompt, like I showed you before, the run dialog, it's not the same in Linux or Windows or OS X. You have to target the system a little bit. And I won't go into it, but I've actually made my firmware that I wrote makes it super easy to target a specific operating system. You want it to run once, because so every time it reboots, it's not going to perform the same attack. I will be updating my firmware soon to make it do that. Time delays, a lot of timing scenarios. I know a lot of this is very vague when I talk about it here. Unfortunately, I don't have enough time to walk through an entire attack, but maybe at the end we'll see if I can show you how one is developed. And then make it look normal. If it's back in the mouse, you're shipping it out. Some attack scenarios. I'll just talk about the first one. One of the first scripts I wrote. We're good with ROT13, right? Everybody knows the Caesar cipher. You replace a character with a character that's 13 up from it, so you end up rotating the ASCII, the American character set. So the attack that I wrote is actually a batch script because I wanted to use native resources. I don't need to download a file or anything. It pops up a text editor, types out this batch script, saves it, runs it. ROT13's all the files in my documents and then hides them. So if you're a normal user and you open up my documents, all you see are folders, and every single file you have in your file system is now gone. And even if you do unhide it, they're all ROT13, and the file extensions are ROT13. So you have absolutely no way to open them. And this is all just using batch. This wasn't downloading, this wasn't anything fancy. And then of course, the scenario was if your roommate owes you rent, you plug this in, and after a couple of minutes, they will pay your rent or be very sad that they've lost pretty much all their files. Because manually redoing this is really not possible. But then I wrote a script, obviously, that undoes everything. You re-ROT13 everything and unhide it. But some more practical scenarios. In Windows, you could have a TFTP server pop up, send some files back, add a local user, reverse SSH. You can have it download files. You can actually type out binary. Like I can copy a file by typing it out and saving it. So you type it out in hex, like this. The scenario is it gets typed out and then reverted back to a binary and then executed. And the glitch has that capability in Linux, in Windows, and in OS X, so that it'll type it out. It takes a long time, but it'll convert it back into a binary file, execute that in any way or shape you want. Or you can go to a website and download it. I mean, anything you can do with a keyboard at all you can do here. And I challenge you to try to go a day without using your mouse. You'd be surprised at how well you can get around any operating system without a mouse. There's a lot of function keys and maybe non-common scenarios where you're using Alt F3 or something, and that pops up these things. But there's a lot you can do that you might not be aware of just with a common keyboard, which is our next scenario. Keyboard, take it apart, lots more screws, don't lose them. You always end up with like one lost screw. It doesn't matter. So every time I open it up, there's one more lost screw. But you can see here, the white surface area is actually, when you're pressing down on the keyboard, that's what it's pressing on. At the very top, you see a built-in USB hub. Super, we didn't have to buy one. It came in there. So take it apart, we remove the little keyboard thing. That's a little big to pass around, but it's a sheet of metal, so it's really easy to remove. And at the end, you guys can come up here and look at it. So what we're going to do this time is instead of bedding our own USB hub, we can use the one that's already built in, which is nice and handy. Unfortunately, we're going to sort of disable that one, And my thinking is most users, you generally, if you're doing a security testing, you don't target the security aware. You're not going after the IT guys directly. You're not going after the security personnel. You're going after, not to generalize people, but like marketing and HR, business, the people that we try to govern as much as possible. Not upper management. So yeah, security people, IT, and upper management. Anything with a C in the front of their name, those are the off limits people. So yeah, these are the people we're targeting. So when they plug in the keyboard and then they want to use a flash drive with the the USB hub in the back, and they plug it in and it doesn't work, they go, oh no. Then they plug it in the other one. Hey, it worked. There's not like, they don't ring you up all of a sudden and be like, whoa, hold on. I found that one USB port on the back of my new keyboard doesn't work. Let's call in the IR team. Not a high scenario. Probably not going to happen. So if one USB port is broken on the back, that's fine. The keyboard itself is going to be good. It's still going to work just fine. And in this case, we avoid soldering it all to the device. So if we wanted to do this attack in if you were physically on site and you had the screwdriver with you, you can perform this attack without bringing a soldering iron with you, because that stands out sometimes. Okay, so what we're going to do, if you see the back of this right image, you see the wires kind of coming in. So this entire segment here, this whole board, all it is 2 USB ports. There's no other stuff going on there. So we know that all of these wires are for these 2 USB ports. And there's this, the data wires, there's power, and there's ground. So ground can be shared amongst everything. So we don't want to solder, so we'll try to leverage that. We flip the board over, and all we have to do is there's the plug, and then there's where the cable comes in, and there's strips of wire that are going between the 2, essentially, little bits of copper. We'll just cut it with a knife. That is not a very advanced technique. Anything sharp, you scrape it off, and now we've severed the connection. So anything you find around, we're going to cut that. In theory, you could just cut the data, so if they plug it in, the nice fancy lights come on to their device, but it doesn't do anything. That's totally fine. But in this case, I just cut it all. So you plug it into that particular USB port, doesn't do anything. And this is the final result. What I did is I basically took the same one I had before. I had the wires soldered onto the top of the glitch, and I shoved them into the socket. That's all it took. So the connector has, inside the connector, there's the wires that run, and they have little clamps. And so it's a wire, a clamp, and then a little plastic case, a really cheap plastic case that's very flexible. You just take the wire in, which has a little bit of exposed metal, and shove it in, and it presses hard enough against the plug, what exists, that it's going to make a circuit, so you can hold it together. So I didn't have to do anything other than shove it in as hard and hope it's not loose. It's not a very advanced, stable technique, but pushing in wires and hoping they don't come loose, or taping them or something like that. That's what my life resorts to. I don't really go terribly advanced with things. Duct tape and WD-40 are the way to go, or in this case, probably electrical tape. And non-conductive material. So now we've got our Trojan keyboard. We put it all back together, and skipped ahead. We put it all back together, and it looks exactly, again, it's the same thing. I didn't have to carve out any space. That space in there fit just right. Was able to put the keyboard back together, and you can see it up there. It all fits very nice and easy to do. And again, any keyboard you come across with a USB hub built inside. I'm making a mental list. I probably won't make an actual list, but I do now I go into stores in the US like Best Buy or something, and I'm like, ooh, yes, yes, yes. Oh, why didn't you put a USB hub in there? But around here, it's a lot easier to find a variety of them. So we'll move on to another one. So far, I've taken my Trojan hardware, and I've used an additional USB hub to man in the middle with it. I've used an existing USB hub inside to perform my attack. In this case, I'm going to be doing more of a man-in-the-middle attack embedded in the hardware. So what I have here is a very old and very dusty point-of-sale card system. So this is the keyboard that gets plugged into a hotel or retail store or whatever. And when they're taking your customer data and they scan it, and if they have to type anything in or if they have to scan anything, again, this one's a little old. Nowadays you have your pen pad version. So this is more common sort of at hotels now. But you've got your card swipe, and then you've got your keyboard, and that gets plugged into the point of sale system. What I'm doing here is you can see on the left, and it looks weird, that's actually the magnet used for the credit card reader or the gift card reader or any sort of card. There's different sort of layers, but there's a specific one used for normally like the financial stuff. And then it's a really old PS2 keyboard, which makes it convenient for this scenario because PS2 is easier for me to man the middle than USB, but USB is also possible. So we've got those two things. Those two things are good for us. This also didn't involve any soldering at all. Actually, the glitch in here doesn't have the little wire sticking out. It's all straight up plugging in things. So we saw the pinouts. You can see them better here. Again, looking up, spending about 2 minutes on Wikipedia will tell you what these lines are. Unfortunately, the color coding isn't as good. So black, probably ground. The rest of it was just testing until I finally figured out which ones went back and forth. So there's 4 lines again. You can look it up. I'm not going to go through all the PS2 connectors. So I'm going to use the same thing. This is a little bit better picture of what I was talking about before. You can see it from the top, where I'm essentially going to be shoving wires directly in there where the other wires already exist. And that's what that big mesh of things at the top is. We've got the 4 wires that are coming from the glitch to the PS2 connector, and the original cable for the PS2 connector, they just chopped it off. I'm not going to use that anymore. I don't care about it. The only reason that I kept those little wires sticking out there, I just cut it later. But it was easier to shove in the connectors than it is to solder new ones on there. So got the connectors. It's going into the back of the glitch. The glitch reads in the keyboard. So when you're typing in stuff, it's like, oh, cool, I've got keystrokes. I can replay those. In case you don't know, most of the credit card readers just type out ASCII code. So it's not like when you swipe a card, something super secret happens. You just swipe it, and it types it out. So when it plugs into the point of sale system, you click on a window, or you click on a field, and this types out the stuff that it needs. So the credit card, the name, or the gift card name or whatever, and the pertinent information all get just typed in like it's a keyboard. That's how it works. So there's no secondary thing going on there. So the keystrokes from either the keyboard or the card reader get sent to the glitch. The glitch then interprets it and sends it out over USB. So essentially it's like a PS2 to USB converter, but it's a drop. So I can record everything that's going on there. And again, you would close it up, ship it out. The reason the top isn't on this one is because it's horrible to put back together, so you would never see the inside. In this case, something I might have failed to mention is while your configuration is from a microSD card, you can also save files to microSD card. There's no reason not to. It has read-write access. You can also mount the glitch as a storage device if you want to. So in this case, it's if it's got a 4 gig microSD card, you can log for years if you want to and let it sit. So this is a little bit better picture of what we've got going on. Little wires coming in from the connector, wrapping around, going to the glitch, and then we've got a USB connector, and at the very top is where the cable kind of pops out. So we've got that coming out. You can see the mag stripe card reader a little bit better in that scenario on the top. It doesn't really, it looks kind of weird because the keyboard's not on it, but the keyboard on there, it looks like a standard point of sale system, even though it's like 10, 15 years old. And for fun, let's spice it up and add a Bluetooth adapter. So what I did here is right now the code's just set to dump out all of the information I find over Bluetooth. So when I connect to this device with my laptop or my phone or whatever, it'll just print out everything it's got going on. I gave another talk and have worked with launching attacks over Bluetooth too. So you're not sending data as much as you're just command and control over Bluetooth. So if you've done the other scenarios, and this can be done with the previous stuff I'm talking about, if you know that you want to launch an attack in a certain time frame and you're physically around, or you go over, like you send an SMS text, there are adapters for this sort of thing where you could go over cellular network. You can click go and it sends the text and then it gets interpreted and then it launches it. But in this case, I'm using Bluetooth, so I'm just hitting a go and it'll launch the attack then. But here, I'm dumping the data. So it'll go to whoever connects to it. It'll just dump all your information out pretty easily. This is a very, very simple one. It also involves no soldering. How many people have built their own desktop? There's more than that. Come on, we're a lot of nerds in here. Yeah, shamed. So most desktops, you probably know, have this very, very common port that's generally 2 USB ports. And the reason it exists is so you can run a USB line to pretty much anywhere on your case. So the motherboard has USB built in, but sometimes you want USB like in the front of the case. It's a pretty common thing. So these ports exist to have that. So all I did was bought a generic USB to 4 adapter, which is something that you find online. It's very easy. USB to micro USB, and then glitch. And I just plug it in, close it up, walk away. Again, this is a good one for you have 2 minutes scenario alone with the system. Unscrew the one screw that's holding the case on, pop it open, plug in, close it, walk away. And then you've got your timing and everything set up and it'll launch, or you can resell it with this or whatever. So what does the user see? I talked about a little bit. This is the keystroke injection side. What's the user going to come across and see this interaction of like these keystrokes doing weird things? They're not sure what's going on. Just plan ahead. Think about, again, the non-stereotyped users I was talking about. What works well for them? If you bring up a command prompt and the command prompt just starts typing, downloading new driver, don't touch keyboard for 5 minutes, the user's going to be like, well, I should get coffee or tea. They're not going to be like, whoa, that's weird. Command prompt, like that's not, the hardware does funny things. Computers are, difficult. So you just see that pop up, and as long as you have a little friendly message at the beginning, they're going to be like, okay, all right, I'm out. Yeah, I'll go to the bathroom or whatever and come back. And then it does all of its stuff in the command prompt. You're launching your attack, and then it, exits. And as far as they know, nothing has happened. Their system in the front end hasn't changed unless you change the background or leave websites up. Users don't know this sort of stuff. There's a lot that goes in the background, shock and awe, and that they're not observing most of the time. So if they can get on, their social media websites and their email, if you do anything else, that's okay. As long as they can get those 2 things, users don't care. So they launch the attack once. It will not attack after that. So I've mentioned this before, but that's a new thing I'm adding on there. So it doesn't sort of do the updating every single time you boot the computer, because they might catch on eventually there. Some things we can do to make it a little bit stealthier. You can clone, so USB devices have IDs. If you're familiar with a MAC address, same concept, except for it's not unique to each device. Manufacturers have their assigned ones, and then they do like a device level one. So I think it's 8 digits, 8 hex digits. I think that's right. So essentially, what we can do if we're doing this from firmware, so I'd have to compile the firmware from source for this one, as opposed to the other ones where you just can flash it. But you can emulate the exact same ID. So what you would do is you plug in your USB device, see what its ID is, go to the code, modify it slightly, and then compile, and then your device, aka the glitch or other embedded hardware, appears to the computer to be the exact same hardware. So even the drivers will load the same. Everything looks pretty much the same when you plug it in. So even that pop-up that looks weird before, you might see several different devices installing, now it's like Dell keyboard, Dell keyboard. That's really not going to show up as something that will really set off any alarms. And we can make it, it's planning the attack, making it look normal, wait a while. So one of the things I'm working on now is user detection. So if the mouse isn't moving anymore, the users are going to use the mouse every 5 minutes. It's very odd that you would have a mouse and sit there and not be using it. So if you can detect when the mouse is being used and wait until it's after 5 minutes, 10 minutes, whatever, and then launch your attack, you're almost guaranteed that the user is not going to be there. And that's something that I'm working on now. I haven't quite figured out the best route to do that. If anybody here has any ideas about that, please let me know. I'd love to chat with you and talk about that some. But I think the user detection side is key for this sort of scenario. So move on from the USB. And again, these are just some concepts for a few attack vectors. I hope that you take away sort of a broader scope of hardware. We'll talk about a Trojan router. Instead of doing Trojan USB, let's do a Trojan router. So we've got hardware, which before was our mouse, our keyboard, our point of sale reader. But whatever hardware it is, we've got our Trojan device, which is like a Trojan router, and then we've got the network that it's plugging into. So the method, and I'll show some pictures that'll make it a little bit easier. Conceptually, what we want to do is come between the motherboard and the jack on the back. So we're going to focus on wired connections. Like we did with the USB before, we cut the lines. We want to cut the lines, place a network adapter on one side, a network adapter on the other. So in this scenario, we have the device. It's going to connect to our router. Our router is going to be connected to the plug that's actually on the outside of the case. And then we're going to charge it by using USB as a scenario. I have a USB-powered hub, and that makes it really easy because 5 volts. USB ports are on practically everything that has an Ethernet jack now. So it's really easy to find those 5 volts that are given to USB inside the case. You can tap onto that to power it. If it's a really big USB hub, you're going to have to find Ethernet hub or router. You're going to have to find some other way to power the device. So getting small USB, good stuff. Here's some scenarios of a TV and a Blu-ray player that I plugged them into. And this is still very much in my beta testing. It's the scenario of I take everything apart. I'm like, the USB attack against the Blu-ray player doesn't really work. What else could I do? Look, there's so much empty space in there. I have to be able to do something. So that's when I decided I should play around with routers. So I haven't actually broken this because this is my TV and my Blu-ray player, and I don't want to break them. So if anybody wants to give me things to break, I would be most appreciative. But I don't really need all my equipment at home to break. So these are mostly just kind of as a proof of concept. So this one is obviously the Blu-ray player. The one to the left is TV. And so you can see here, on the left side, you see the yellow cable coming out. That's the Ethernet jack built in to this router. This one only had one Ethernet jack, so I have a USB adapter to Ethernet going out to the other side. And then I have 2 little lines coming out from the USB, and they're just clamping in to the power that's coming from the device itself. It's the same thing for both of these. I'm using the exact same idea. This is a good picture on the bottom left of the power tap. And these are all parts you can get at they're very common parts. These aren't like advanced, very rare things or something. You can order them online pretty much anywhere in the world. So what we'd want to do is sever the connection, solder it somehow to the motherboard, and then replace the Ethernet jack or tap into the Ethernet jack. This particular router was this Blu-ray player was really nice because it actually had exposed little points for soldering onto. So that one, when I get home, I might actually play around with because I'm much less likely to destroy it. And I might just give up and not care because it's an Ethernet jack and I don't really need it to play Blu-rays. But this one can be put into pretty much anything. I've talked about this. This will be a lead-in. So modifying hardware on the spot. I did all this at home. But you've seen doing the point of sale or the desktop scenario, screwdriver, 5 minutes of access or less, you can plug it in and walk away. It's not like a flash drive sticking out of the back or new hardware or whatever. You can set things to update like an alternate firmware through a web interface, making it very easy. Things I would never do is like open up the TV in a hotel room and stick something in there and then close it back up. That would be something I do not recommend anybody ever do. But if you were doing an actual test, that is not here. I did not do that here. Or I would never do that ever, but I definitely would never do that here. So the scenario is, really, this was theoretically in a hotel room. But if you were in, how many TVs do you see in corporate offices and around here. I mean, you have lots of access to these things, and they're in possibly very sensitive areas. And who takes apart TVs to look for them as the thing that might be attacked? I mean, if you were an attacker, you could just have the nearest TV store, or just keep, pushing stuff on the local Craigslist or wherever to sell and get these in there somehow as soon as they plug it into the network for setup, because you always have to plug it in the first time, the network. You have your back door, you have your window, and even if it's just a 5-minute window, you've got your tunnel out. So some examples of things, to think about when you're doing hardware embedding is, KISS. If you're not familiar with this, it's generally keep it simple, stupid. But in this case, it's keep it small, stupid. So you don't want to be trying to put a laptop inside of a TV. That is not, while you have a lot of features there, that's probably not the best scenario. You're going to run into a lot of issues. So some recommendations, obviously I have to say, I built it, so I'm slightly biased to say that the glitch is something that I would recommend using. But other devices, the Pwn plug is another pen testing tool or hardware device that's out there. It's about this big. It actually looks like a power brick, but it's preset with a lot of these attack tools to make things really easy. You'd have to find sort of more power for it. Any Arduino devices could potentially be used. Some are better than others. Raspberry Pis, which one of the router scenarios was sort of that I'm tinkering with, was using a Raspberry Pi for the router. Mini Pwner, which was the other router that I was showing, flashed with some attack tools on it. There's all kinds of stuff, but you're looking at size and capability. So that's kind of the modifying of hardware portion, and that's been my primary focus, because obviously, built this device. I wanted to see what I could do with that. But the other side is firmware, and I think there's a few more talks, and I'm glad to see it here at Black Hat Asia about sort of the hardware level debugging and modifying. And I think this is another key scenario of things that are easy to do, and the same sort of like, we can ship it out to you, I can replace it, doing the same things. A little bit more difficult to make this super malicious sometimes, but in other times it's not. So if you've never done hardware, let's talk about how you would go about trying to modify hardware. I promise you, any of you guys can do this if you're a programmer at all. It just takes time. You just have to get used to some of the terminology and the languages and stuff. A lot of this stuff is very accessible. So we want to research, when you pop open the device, probably the biggest chip on there is the one you care about. It almost always works out that way. That's the one you want to go after. Whatever's physically the biggest is actually generally the most important. So you look at a couple of different common chip types, like the ARM, Texas Instrument, whatever. You're looking for things, and these are a little more tricky, exposed ports. So those little holes, if you see the board with a lot of little holes in them, if you see some in a row, those are interesting. You should take a picture of that and post it up somewhere and say, what do you guys think this is? Or, could somebody tell me what I should try to test this with? Some common ones are JTAG, which again, tomorrow I believe there's a talk on JTAG. Serial over UART, some other very common interaction methods. So you're looking for those, and then you're looking to see, can you debug it? Sometimes debug means, getting the input-output. Sometimes it means you can modify it. There's all kinds of stuff you can do with these debug ports. And the reason they exist is manufacturers, A, want to be able to test when they're developing, and B, if you ship it back to them and it's broken, they don't want to throw it away. They want to, refurbish it. That's the whole, if you heard refurbished devices, that's what they do. They use these debugs, and they either flash it with new firmware or try to figure out what's wrong, take some chips off, replace a couple things, and then ship it back out and charge you 75% of what they used to. So these things are easy, and they're very common standards. Two great tools to use are the Bus Pirate and the GoodFET, because they will talk to lots of different types of chips, lots of different architectures. They're both very open source, very user-friendly. Some other common ones, FTDI adapter is essentially a serial adapter. And for people maybe a little more vintage than me, are very used to the idea of serial. In the 80s, 90s is when USB kind of took over, but prior to the 80s, or the 80s and further back, serial was very common. That's how everything interacted. It's still very common in hardware. We just don't, as users, interact with it nearly as much as we used to. So it still exists because it's very simple to interact with, and why rebuild everything? So a lot of stuff, and a lot of times debug, dumping information, BIOS stuff ends up being accessible over firmware, or over the serial connection. We're looking at IDEs. Again, programmers out there, or hobbyist programmers. We're all IT people. Nobody wants to raise their hand here. You guys don't like me. I get it. It's cool. It's cool. I'm on camera. Nobody sees you raising your hand. That gets lost almost instantly. Looking for development communities. Awesome. Type in the type of chip. What you do is take the board. You look at the very, very fine print. So if you have glasses, you might need magnifying glasses. Very fine print. Generally say the type would be ARM, and then you see a bunch of letters and numbers. You type those out onto the internet. You get a response, and you say, oh, that's this kind. And then you look for the development community, and I guarantee it'll be massive. Because as far as all the products we buy in the world really revolve around a very small subset of chips. You would be surprised at how many manufacturers, if you open up the case, they're exactly the same, except for the case is different. I mean, there's very, very similar, very common hardware that's used throughout, because it's the best of its line, so all the high-ends use it, or it's the middle of the line, so all the medium brands use it. So there's massive communities out there, and deadlines and such. People are posting stuff online to get, we've got to get it done. I need to figure out how to get this done. And also in recent years, with hobbyists wanting to use these chips for their own endeavors, for either startups or just for fun, you find a lot of communities out there that develop with this. So you'll find open source libraries, you'll find links, big excerpts of code, things like that. So getting started in this, again, the learning curve is maybe not what it used to be even 10 years ago. And then the flashing methods, these are some programmers. The two middle ones, the top one's the GoodFet, the bottom middle one is the Bus Pirate. You've got a couple of other very common programmers. I don't think any of these cost more than $40. They're very cheap, very accessible, because manufacturers want to make it, they've got a big group of people, or they want startups to try to use their chip. Because I'm a startup, and I've got lots of funding, and I might potentially buy 10,000, 100,000 units. Well, my startup is very small, but in the end, if I get funded, it'd be very big. So they try to make it a very low entry level for a lot of these. Jailbreak is obviously everybody's when I say that, how many people's minds is iPhone, Android, that's where your mind goes right away. Oh, jailbreak. But you can jailbreak, firmware as well. Essentially jailbreaking is almost putting it into the development mode version where you can interact in lower levels. You can use maybe default development credentials if they get exposed somehow. You can connect through a lot of the common adapters that I was talking about. It also doesn't have to be very mysterious. A lot of stuff will update over USB. A lot of your devices, you plug in the USB, if you go to the website to update your firmware drivers or something, or your printer drivers or printer firmware, a lot of it takes place over USB or through the network. So these are things that aren't as obscure or bizarre to a lot of people, and a lot of times that'll work as a method to interact or upload your malicious firmware. A lot of things run Linux. Yay! A lot of devices run embedded Linux, older versions of Linux, because newer versions, with their hot sexiness, aren't really the core of it. There's so many drivers in Linux now that are built in that makes the kernel massive. But all they need is a TCP/IP stack and some controllers and some basic commands. So a lot of times you find older versions of the kernel, which could be used for exploits, older versions of tools. But you've also got, it's Linux, so you can compile something else for it, which makes it very easy. It's GNU, and by the license, it's required to be published. So is it published? Sure, they published it, on this really, really obscure link, and that has no links to it anywhere on the web, and robots.txt says you can't touch this. That's where they put, my source code. But it's technically you're supposed to publish it. A lot of times you'll find stuff that's half open source and half not. They'll do, the lower level will be the open source, but they have some closed source versions in there. So everybody wants BSD, because BSD says do whatever you want, don't tell anybody, we're cool. You have things, so this Linux is compiled for not the same architecture as we're used to. It could be compiled for ARM, which a lot of phones run, or a lot of the other architectures also will run Linux, or people have ported it over. So that's the ideal scenario, because people, I'm sure the significant number of people in the crowd, I'd like to think all hands would be raised, but I won't ask because I don't want to be let down, or have experience with Linux and porting over stuff using existing tools, very easy, and these are, can be small and very embedded devices. So things that run Linux, you can look up online that they run them. It's a little harder to find sometimes. Printers, every printer you've ever touched ever runs Linux. TVs, there's some good TVs out there that run Linux. Same thing, DVR, DVD, Blu-rays, routers, lots of routers. You can run it on a watch. I mean, Linux runs on everything, or the giant Linux geek community will convert it to Linux. But these are devices that you're not necessarily modifying. They're going to run Linux natively. And almost anything you can ping, because why rewrite the TCP/IP stack if you can just download Linux and run it? I'm running low on time, so I'm going to go through this part pretty quickly. Flashing open source firmware onto routers is good. That's what I was talking about before, using those routers. And you can do it with across brands, tons of different routers. DDWRT and OpenWRT are very commonly found. So not security, hackery stuff. It's just you can get a lot more features with it. You can, configure it. These are some just ones I picked up offline. The one to the far right is actually the one that I was using in the scenario. And then you can see it, these are the ones cracked open. If you want to embed them, obviously you want to remove the plastic case because you have no reason for it. But also sometimes you have to open them up to modify them. In this case, you can creating this Trojan router. The idea that I had that I haven't implemented yet is essentially you flash it with the open source firmware, but you clone the normal web interface. So again, users have no idea because the open source firmware is very advanced, whereas normally the home one is not. So you're cloning it, you're mapping everything out, but then your Trojan firmware that you can ship by itself. So this isn't embedded. This is just reselling a router. Could enable a VPN with your credentials, could create a reverse SSH connection back out to you, could have the hacking tools that get launched to attack the inside of the network, whatever. So kind of in conclusion, what kind of devices can we attack? I want to say everything, but it's pretty much everything. I just listed a few things. But what has firmware? All devices. It's just how can we use them in an attack scenario? Some really quick countermeasures. Purchase from a reputable source. If you're monitoring your network for these sorts of things, if your printer or your TV is making SSH connections out, you probably want to look into that. That's not normal. Disable debug parts if you're a hardware manufacturer, and enforce some sort of update authentication for firmware. I've got a bunch of resources listed. I'll probably put these online. There's a lot to go through, but this is sort of some stuff. If you're local here to Singapore, check out Kim Lim Tower. They have a lot of electronics and stuff in there. I was there the other day. It was like a kid in a candy shop. It was awesome. I'd like to thank a lot of people here, but because I'm short on time, this is the end of my presentation. That's my creds. I think it'll cut off on the video. I don't know if I'm done with being up here. But I can try to take a question until they tell me I have to leave. Or not. Yeah. With the rubber ducky, I kind of paralleled their project some, and then they got out way ahead of me. The idea of the attack scenario is pretty much the same. My focus has been sort of embedding it. So you can port the attacks from the ducky, which is another device that can do keystroke injection. You can port the devices between that and some other hardware. I focused on embedding and also having you able to run multiple attacks, and also being able to connect things like a USB or a Bluetooth adapter in. So my pinouts allow you to connect third-party hardware into it. So I tried to, most of my idea was not just to have it be keystroke injection, but to be able to modify it to be lots of different things at once. Thanks. Any other questions? You're yawning, you threw me off. All right, this stuff is up here. I'm sure they're switching out for the next talk, but if anyone wants to look at the hardware real quick, I'm going to try to find somewhere to set it out, because I'd like people to be able to poke at it and see it. So thank you very much for having me here.